In this video, I will answer the question which of these two numbers is larger. Of course, by doing so, I will provide a little tutorial for you on how to approach problems which are similar to this one. As you can see, we are comparing these two numbers to each other. Both of these numbers are really not that convenient to work with, as let's say numbers 1 and 0. So the idea here is to make a constant 0 or 1, which is easier to work with. When we are comparing two numbers x and y to each other, like this, and in the circle we need to put a sign, a relation lesser than, larger than, or equal to. For example, if x is smaller than y, then we know that y minus x is larger than 0. We also know that x divided by y has to be smaller than 1. This is why we are going to take the numbers which we have here and manipulate them to get form which is easier for us to work with. In this particular case, we are going for this option, x divided by y is compared to 1. We can make this constant number 1 by dividing 50 to the power 50 by 49 to the power of 51. Then our problem becomes comparing this number 50 to the power 50 over 49 to the power 51 with the number 1. As you can see here, 49 is 50 minus 1 and 51 is 50 plus 1. So everything revolves around these three numbers, 49, 50 and 51. And from here, the ideas on how we could tackle this problem just keep piling up. So let's write number in the denominator to be to the power 50, just to have it on the same power as the number in the numerator of this fraction. So we have that 50 to the power 50 divided by 49 to the power 51 is equal to 50 to the power 50 divided by 49 to the power 50 multiplied by 49. This is then equal to 50 over 49, and that is going to be raised to the power of 50, and we are left with multiplication with 1 over 49. As you can see now, we have 49 here in the denominator. So the idea is to write 50 over the number 49. So 50 is 49 plus 1 divided by 49 to the power 50 multiplied by 1 over 49. So this is then equal to 1 plus 1 over 49 to the power 50 multiplied by 1 over 49. And this is great because it reminds us of a famous sequence where an, the general term of that sequence, is defined as 1 plus 1 over n, and that is going to be raised to the power n. Of course, n is a natural number. This sequence, as you know, is used to define Euler's number E. So E is defined as a limit when n approaches infinity from the positive side, 1 plus 1 over n raised to the power n. And the property of this sequence is that 1 plus 1 over n raised to the power n is smaller than 1 plus 1 over n plus 1 raised to the power of n plus 1 for every natural number n. So an has to be smaller than an plus 1, which gives us a monotony of this sequence by which it always rises but it never becomes larger than this number e. So for every natural number n, a general term of this sequence 1 plus 1 over n raised to the power n is strictly smaller than e. and approximately this Euler's constant E is 2,718 and so on. It's not that important to us now which decimals come after, but the key point is that this E is strictly smaller than 3. That's enough talk about this sequence and number E. Let's return to our problem. As you can see here, we have a 1 plus 1 over 49 raised to the power 50, and we can write that as 1 plus 1 over 49 raised to the power 49 multiplied by 1 plus 1 over 49, and then we have multiplication by 1 over 49. And from this story which I have told you previously, you can see here that this part 1 plus 1 over 49 raised to the power 49 is smaller than E, and that is smaller than a constant 3. So we are going to plug this information into our problem. So this is going to be smaller than 3 multiplied by 1 plus 1 over 49 multiplied by 1 over 49. Now we have to compare this number here to 1. So let's do that. So we know that 30 is smaller than 49, and that means that 1 over 30 has to be larger than 1 over 49. So our number 3 multiplied by 1 plus 1 over 49 multiplied by 1 over 49 has to be smaller than 3 multiplied by 1 plus 1 over 49 multiplied by 1 over 30. Number 3 and 30 are going to cancel each other out, so we are left with 10 here, and that is 1 over 10 multiplied by 1 plus 1 over 49. So this is then equal to 1 over 10 multiplied by 50 over 49, and when we cancel out 10 and 50, we are left with 5 here in the numerator and 49 in the denominator. And as you can see, this is strictly smaller than 1. When we return all of this, we see that 50 to the power 50 divided by 49 to the power of 51 is strictly smaller than 1. Of course, you can multiply this entire non-equality by 49 to the power of 51, and then you get that 50 to the power 50 has to be smaller than 49 to the power of 51. As you can see, the initial idea for problems like this one is to make a term that is comparable to 1 in our case, or in some other cases to 0. And then see where that will lead you to. Thank you for watching. I hope that you have enjoyed this video, and if that is the case, please like, share, subscribe, and leave a comment. If you want to see some more of my work, I suggest that you watch this video next.